The auroras, known as the aurora borealis, northern lights, in the northern hemisphere and the aurora australis, southern lights, in the southern hemisphere, are stunning natural light displays, most visible at higher latitudes in the evening sky. Unlike celestial phenomena like meteors and comets, auroras are atmospheric events. But what causes them? Although they occur in Earth's atmosphere, auroras are driven by forces originating from the sun. The sun's corona, its outermost atmosphere made of plasma, ionized gas, generates the solar wind, a stream of charged particles, mainly protons and electrons. When these particles encounter Earth's magnetic field, they are funneled along magnetic field lines toward the north and south magnetic poles, entering the atmosphere. Earth's atmosphere, rich in nitrogen and oxygen, plays a key role in this process. As solar particles collide with nitrogen and oxygen atoms, they strip away electrons, leaving ions in excited states. These ions emit light at different wavelengths, producing the vibrant auroral colors. Oxygen collisions typically result in red or green light, while nitrogen collisions produce green or purple hues. Auroras vary in intensity based on solar activity. During periods of low solar activity, when the sun has fewer sunspots, fewer high-energy particles reach Earth, and auroras shift closer to the poles. In contrast, heightened solar activity, marked by larger plasma ejections, sends more particles toward Earth, occasionally expanding auroras to lower latitudes. For instance, the aurora borealis has been observed as far south as 40 degrees latitude in the United States. These mesmerizing displays generally occur at altitudes of 100 kilometers, 60 miles, but can range between 80 and 250 kilometers, 50 to 155 miles, above the surface.